streaming from the ECP. I want to still quickly share my screen here and show you what this is all about. So we are on the ECP here. I hope everybody can see the screen. And the ECP is a speed dating event. It is currently live here in Frankfurt. And the nice thing is the session on the 25th to the 26th of February. And it's a digital format. What the nice thing is you can do really speed dating. So you're making appointment with other people lasting something like 10 to 20 minutes. And the nice thing is you're getting really in contact with a lot of people that have a fancy technology background so that they can meet everybody. If you want to check in for the 25th, 26th, we also have reduced pricing if you're interested, so we can share that with you if you're interested. So send us a mail, but you're checking in here. The nice thing is it's the European Chemistry Partnering event. It's focused on chemistry, but it's really an industry speed dating event. The nice thing is if you're seeing how many sponsors are there, who is here, you can look on their website. You're seeing big names, small names, large name, everything in chemistry, but also investors. You also see big companies like Deutsche Bank, for instance, and you can scroll through that and see all the logos of the companies. So I can only recommend everybody to simply have a look and to do things like that. With this one, I want to stop the part on the ECP. Let me share quickly the link. If you want to go there, you can check it out on the internet. And then let's start. Yeah, I know. Just somebody else doing it. Yeah. Okay, thank you. It's the team behind that. Just as a background, maybe because somebody's asking here in the room, so we might have questions. So if you have a question here in the room, speak loudly, so that the other people can hear it. Yeah. Otherwise, I will rephrase the thing. Yeah. Yes, so I'm out of my concept now. So let's start. And we're starting with a quick introduction from the network TraWeBa. Maybe as a background, because of the people in the room, we had one session before about scalable sales processes before, how to really build networks. The TraWeBa network, the big network, was built via the network effects, which was a scalable process, what we presented before. The network has something like 2,000 participants in the CRM system already. There are only 6,000 to 8,000 people in reach. How we can people reach in the battery community. And if you guys are interested in using the network, please contact us, either me or Maximilian, because the network is really meant to get in contact with other people in the battery industry. And it's also, I think, a very nice example how you can grow a network within 1 year and how big it can be. Okay, with that, having said that, I will hand over quickly to Maximilian, who will start and simply presenting quickly TraWeBa.
Yes, thank you very much, Holger, for the nice introduction. I will share my screen now. Please let me know when you see something. So that should do. Perfect.
We can see you.
Nice. Then, yes, hello and welcome everybody from my side as well. My name is Maximilian Wagner. I'm the cluster manager of the TraWeBa network, and I will be the co-host for today's event. We have a very interesting lineup for today, but before to start into that, let's have a very short introduction or overview of the network. Holger said already a little bit about it. So, yes, what are we? We are a big German-wide network. And for networks, the size matters. We are connecting over 800 companies along the whole battery value chain. And because we're consisting of 10 different networks or network partners, we can reach every federal state in Germany. We are funded by the German government, and our goal is quite simple. We are funded to support you. We want to support you with our network. We want to support you with our contacts, with our events, and also with our expertise in the market. So please contact us, join our network, and then together we can develop a better battery industry in Europe and also here in Germany. I promised a very quick introduction. I hope I got your interest. If you want to get into contact, write us an email on info@TraWeBa.de or visit our website. But I think that was already enough as an overview for our network, and let's start with some of the innovations. And I think then back to you, Holger.
Yeah, sorry, I muted myself. We're starting to start with 𝗕𝘁𝘁𝗿𝘆 on helium tight solutions. They are not here these days, so we are starting therefore with William. I think what was talking about the future circular. The reason is you want to unlock the full potential really of every battery. I don't know. I've seen William currently, so I hope you're in the room. So please unmute yourself on the floor here. You have exactly 4 minutes.
Does it work even if I go into full screen mode like this?
Yes.
Amazing. Hi, everyone. Amazing to be here, and thanks, Holger, for inviting me. I'm William Berg, founder and CEO of 𝗕𝘁 Systems, and I'm incredibly passionate about circularity. So anyone out, in the audience in circularity of batteries, I'm speaking to you. My brief background has been in battery circularity for 5-6 years now, and it started at Northvolt in the recycling team, looking on reverse logistics, getting batteries to recycling. And my only thesis here is that circularity comes from being commercially viable, quick transactions, making sure that every battery has its proper value captured. So in the audience from the automotive and battery industry, circularity comes from 3 key parts. It's maximizing the value from each battery, like selling it to where they should go, whether that is reuse, repurposing, or recycling. And while doing so, keeping sure that it's all compliant, making sure that those, all of those 4 C's are managed. And then thirdly, doing this now for a couple of years, it's a headache. So streamlining those processes is a very, very big, important thing to make circularity happen. So why and how can I speak about this with such confidence? Well, it goes a little bit back to my background at Northvolt, looking on the recycling side of this, but we've been doing this for 5 years now, buying and selling batteries for reuse and recycling, and really doing those end-to-end transactions. Buying batteries on our own books, selling them to reuse and recycling, and doing all the logistics ourselves. And we've been doing this for to over 20 countries. We built a really great platform that fulfills this transaction. And in our network, now speaking of networks, Holger, there's now over 500 companies in close to 50 countries who either wants to buy for reuse or for recycling. And what I'm quite excited to share with you is that bringing this all 5 years of experiences to one complete end-to-end system. And we're relaunching starting in March, and it's in this phase 1. It's inventory management, deal room, and a circular marketplace. And we just launched this landing page, or this waiting list for joining that pre-launch today. So
William,
if you
William, sorry, we're still seeing your starting screen.
Oh, no way. Okay. Wait, that's weird.
Just unshare, reshare.
Does it change now?
Yeah.
Yes, it has changed.
Okay, it's because I went into anyways, this second slide, you probably got it. 3 points: maximize value, keep trading trajectory, simplifies the sale process. We've done this for a couple of years, trading all over the world. Good platform, big network. We know what we're doing. And finally, if circularity is on your table, please find a phone and take a picture of that QR code, or you can go into this website, 𝗕𝘁⁰ and we'll get you into the next generation of trading batteries for circularity as soon as possible. So thank you very much, and hope to see you soon.
Yes, thank you. So sorry, I think I haven't noticed that you've seen that. But one question: where are you located exactly?
Oh, Stockholm. Yes, Stockholm, Sweden, but work globally.
Yes. So any questions from the audience?
What type of battery do you use?
What type of?
So we're agnostic. We mostly look at cells and modules. We have shipped complete battery packs, like EV battery packs. Modules and cells is what we look at. Sometimes we look at scooter batteries as well, but that's not as interesting for us. It's not as big of a problem. So automotive modules, cells, and sometimes packs when there's a big recall maybe, and so on. So currently we're handling a recall of battery packs in the US.
So always lithium-ion batteries.
Yes, yeah, lithium-ion batteries. So not lead acid in typical ICE cars. Maybe that's a good point.
From the mobility.
Yeah. But also stationary, like it's the lithium-ion and can go into the stationary as well. So, but they haven't really come to an end of life yet, and so stationary is typically our type of buyers. They can take automotive, put them into stationary. But any type of transactions of, let's say, over 1 MWh is something interesting for us.
With if I may comment, strong limitation about the use of stationary battery recycled from the electromobility.
Yeah, I agree. And currently, the Second Life industry is having a really tough time competing with new LFP systems from China. So I'm not really bullish on Second Life at the moment. It's probably going to go to, like, recycling is probably going to be a better place to put used batteries. What we're looking at the moment, and our core focus at the moment, is actually unused batteries. We see a lot of OEMs and other players in the industry have a lot of extra inventory. We call it idle, so they're not going into their processes today, or they just want to liquidate these assets.
Very interesting. Yeah.
Okay, thank you very much. I think we have one. I think Frank Richter's question. I think it was answered. The circularity of LFP batteries. Otherwise, Frank, please contact William directly. How do you determine the health of batteries? Is one other question. And all the other guys, please contact William then directly. So it's the last question. How do you determine?
How we determine? So we help facilitate the transactions. We have one partnership with a Finnish company called 𝗕𝘁, who do an EIS test on modules. We see ourselves as that network bringing different testers together. There is currently no equipment anywhere, as far as I know, that can test all modules, packs, cells reliably. So what we want to do is help sellers to sell their batteries. And if they have data, amazing. If they don't, it will impact the price, but the batteries can move. So we're there to carry the information to buyers rather than actually doing the tests.
Okay, thank you very much. And I think then we are coming now to the second pitch.
Thank you.
Yes, then I will take over, and I'm pleased to introduce to you 𝗕𝘁⁵. He's the sales director of 𝗕𝘁⁵, and 𝗕𝘁⁵ is an expert in modular battery storage devices. And battery storage capacity is already increasing really fast, and it will play an important role in the future, especially if we start to mix more and more renewable energies into the energy mixture. And so with this, I'm really looking forward to the presentation. And Konya, I haven't seen you in the chat, but I hope you are there because the stage
Yes,
now
I'm
is
there.
yours.
But Max, can we maybe skip my presentation to the next one because I'm sitting in the car and I needed to drive on the right side. So if I can do the next one, it would be perfect.
All right.
Yeah,
that is, of course, no problem. We can do that.
Okay, thanks.
Let me quickly then hand over here. Let's go then to the to 𝗕𝘁·𝘁𝗃𝗁𝗁. I have seen him somewhere. It's about ultra fast and biodegradable batteries. He's coming from the EAP Fraunhofer, and so the floor is yours, 𝗕𝘁. Where are you?
Yeah, thank you very much. Do I need to share the presentation or do you have? Okay, I didn't practice this, so sorry.
That's here.
Okay. You can see it now?
Yes.
Okay. Yeah, very welcome. And good afternoon. I'm a researcher at Fraunhofer Institute for Applied Polymer Research in Potsdam, located in Germany, for about 15 years, focusing on material development for mainly on 3D printing, medical technology, and bioelectrochemistry. My work bridges chemistry, biology, and engineering to create innovative and sustainability solutions. One of our latest breakthroughs is 𝗕𝘗𝗿 I will present now. And it is designed to tackle the environment challenges on the one side and modern energy storage. So this is focused as a problem. Actually, we all know modern battery production heavily relies on petroleum-based materials and resource-intensive mining. The traditional take-make disposal approach leads to environmental degradation, toxic waste, and resource depletion. Batteries powers our world, but the production of the disposal are far from sustainable. Can we change this? And I like to come up with a newest project. Here we see one part of the solution. It's actually worked on my colleague Hannes. You see on the right corner. We utilize mycelium growth, modification, and sustainable materials to build biodegradable batteries. Our approach replaces harmful components with organic and compostable alternatives. We are creating a battery that not only delivers high performance, but also minimizes environmental impacts. This is shown in the next slide. Here's the principles. Our 𝗕𝘗𝗿 technology consists of 3 functional layers made from fungal mycelium. It's not only fungal, we also concentrate on paper, for example, like waste paper. And I had hard times to find newspapers here in the Institute, actually, in these modern times. But first, on the left, conductive layer, organic metal-enabled charge transport. Chemical layers, electrochemical layers, engineered biomaterials, stores and release energies. And the structural layer is also, you can think, the surroundings of the battery is also made from mycelium, for example. And on the left side, you see the anodic and cathodic films that we will introduce with organometallic material that is found in nature. And on the right side, you see the very ultra-fast chemical that we know it could work in from literature. And this is like the combination we want to realize now. And here are two examples from organometallic compounds. We all wear it inside in our blood or in the trees in the green color of the leaves. And these metallic compounds are redox active. So the principal use for these kind of batteries. And yeah, this is the idea. We work like now half a year on it and have very astonishing results so far regarding the conductivity of mycelium layers. So we started this, of course, first. Yeah, thank you very much. I'm willing to hear all interesting early adopters, scientists, and so on that you can give me some support. Yeah, thank you very much.
Yes, thank you. Very well in time. So you're looking for investors and partners, correct?
Yes.
Okay, so any questions towards Dschiðrich?
Just
So presently, what are your battery applications where you have tested it?
We have no applications right now. We are concentrating, one thing is like batteries that you can use in consumables and throw away afterwards. So it is compostable. Like in these music cards, for example, if you use nowadays, you know, probably from a birthday card you open and a melody starts, and they nowadays they still use lithium ion batteries full of metals and poison, and you're not supposed to dump it in an ordinary waste, but yeah, this would be a possible application where you could use such an organic battery. But yeah, my focus is actually in the development in this battery as a whole first.
Mr. Mayer, I know it's very early stage, but do you have any idea of the time to market for such type of applications?
Market is beyond the next 5 to 7 years, I guess. Yes.
Thank you.
There's a question from Dr. Zeni.
Yeah, Mayor, thanks for the interesting outline. What are the potential for these kind of organic batteries in terms of large-scale production in the future?
Yes, large scale. I need to differ between the mycelium, probably. The colleague is very into it to scaling up problem, because myceliums are growing. They're of course bio-based and living organisms, and they don't behave like chemicals that you can force them in row-to-row production, for example. And that's why we also go for the paper solution, and there we see much more possibilities to get an early stage to reach a commercialization quite early.
Yeah, interesting.
Yes.
Yeah, one thing to connect. I had put in the chat the direct link from William. So if you have seen it, I post now the thing from 𝗕𝘁_𝗏𝘁. So go on LinkedIn, connect directly to him. And I see Konya, so therefore we can then go. Is there another question? We would have time for one question. No, if not, then we are walking over and then we are coming then to the next pitch. So
Very good. Thank you. And as we already had the introduction, I guess I can just start.
Perfect.
And I try to share my screen so you can also have some visual support. Sorry for the first slide being in German language, but I will explain what's on there. It's not much. Okay, so 𝗕𝘁 is a Norwegian company doing battery systems. And the idea, where we come from, what we do, is coming from the USP power supplies, so uninterruptible power supplies from the data center and telecom industry. And there you typically have a grid. So on the left, we have a grid, and you have a rectifier, you have an inverter, and then you disconnect the load from the grid to have an uninterruptible system. And to do this, you have batteries in between. And those batteries are not used in 99.9% of the time. And 𝗕𝘁𝘁𝗃𝘁𝗁 engineers thought, hey, what about we can so not only use this battery in one direction to supply the loads, but let's make this rectifier a bidirectional rectifier inverter, and which was not possible so far, to make this lazy batteries usable for example, grid support, frequency services, and arbitrage, things like this. And we developed this bidirectional inverter called 𝗕𝘁𝘁𝗃𝘁𝗁 box, so we call it 𝗕𝘁𝘁𝘁 box. And this is a versatile tool, so you can use it as a bidirectional inverter or rectifier. You can use it as an inverter rectifier in a USP system, UPS system, and you can use it also as a DC-DC solar converter, just with a different software. And we use this to build, so obviously all the slides are in German, sorry for that. We use this to build a battery system consisting of modular inverters, modular batteries, and we connect those inverters to three-phase systems. So from left to right in this power racks, we have a three-phase system, and then we put them in parallel to create more power. So in this cabinet, for example, 50 kilowatt, 50 kilowatt hour battery system. And we use 48-volt batteries, put them in parallel, which is different than what you can see in the market, but it comes from this telecom data center background. And what we can do now with this system is to build a battery system that at the same time can be a 48-volt uninterruptible power supply. So this is an idea which is interesting for the telecom industry, basically for base stations and anywhere you want to have uninterruptible power for 48-volt loads, but at the same time offering grid services to earn additional revenues from the battery systems. So this is basically where we came from, what we did, and we found that this system is not only good for power supplies and as a small battery system, but we can also build big battery systems up to the megawatt scale. And the key is really this 𝗕𝘁𝘁𝗃𝘁𝗁 box, which is possible to scale in up to the megawatt range. It's very redundant, very modular. It's hot swappable. So you can change modules, you can do the service while running the system. You don't have to shut it down because it's also 48-volt technology. And it's very easy to service, to maintain, to install, because there's no special high voltage training like in a common battery system that you would expect from the system. So yeah, and basically that's it for this pitch. And just one last slide. So you can do one system and you can scale it also up to bigger systems just by putting them parallel on the AC grid. So you can also really scale it to the megawatt range. Thank you.
Thank you very much for the nice presentation. Are there some questions from the audience? Otherwise, maybe I start with one. You mentioned the bidirectional loading or the bidirectional use of the batteries. That's a very important topic as well if you look into the electric vehicles, to use your vehicle not only to drive, but also to use it for the grid market. However, I don't see a lot of that already realized in the economy. What's your opinion? Like, what are the crucial steps you need to get this bidirectional idea into the market and into action?
Yeah, and what you say, thanks Max for the question. What you say is really, it's an opinion. So my personal opinion is that the critical issue for the car makers, for example, to offer this vehicle to grid functionality, which could be enabled also with our hardware, with our rectifiers or bidirectional inverters, is that the battery warranties are the critical thing for for the car makers. So they guarantee 8 years of warranty on the batteries. And if you now start using the batteries for doing vehicle to home, which generates much more cycles on the batteries, this can kill the warranty conditions for this 8 years or specific kilometer range on the batteries, because the demand or the energy demand to cycle the batteries in your home or anywhere else with the load are much higher than for just driving with the car. Because imagine you drive 300, 400,000 kilometers, and this typically relates to a cycle number of maximum 1,000 cycles of the battery. And what we see in the stationary storage is typically we want to have 1 cycle a day, which means you have 1,000 cycles after 3 years. And this is obviously a problem for the warranty conditions in the cars.
We have a question here from the room.
Just one more question. 𝗕𝘁 is your name, sorry. Have you tried anything like LFP or other type of cells for your system?
Yes, so basically we are battery agnostic, we say. So what we care about is 48 volt and 19 inch to fit it into our systems. And we have been using NMC batteries. We have been using, or we are using LFP batteries, not so much NMC anymore because they are more expensive. They have issues with critical materials, so people think they are not so environmental friendly. We have also been talking the first pitch about the second life batteries. So we are looking into that, but we see there is no really second life batteries in the market yet. And if you want to get it, it's more expensive than, for example, new LFP batteries. So our customers are not really asking for more expensive batteries, even if they are second life.
Okay, so you are building up on LFP right now. Okay.
At the moment, this is what the market is asking for, yes.
It's safe.
Basically because the warranty, the performance warranty we can give is high. So a lot of cycles, the depth of discharge and the performance is very good, and they are cheap. So that's a main point.
The level is higher.
Sorry?
The security level is higher than
the security level as well, yes. So there's also security and environmental arguments, but this is not the main arguments typically for people to use it.
Okay, interesting. Thank you very much.
Okay.
And with this, I would say perfectly in time. Thank you again, 𝗕𝘁, and we are moving over to the next pitch.
Thank you.
Yes, let me introduce quickly the point is lithium, fast charging lithium-free sustainable batteries from 𝗕𝘁𝘁𝗿𝘆. Are you there? I don't see you. Here we go.
Yes, I'm here.
On the left side. Jen, over, the floor is yours. You have 4 minutes, as you know, and 4 minutes Q&A thereafter. Just one reminder to 𝗕𝘁, there's a question also on the chat. Please check the chat and then respond there. So let's hand over to 𝗕𝘁𝘁𝗿𝘆.
So thank you. It's a pleasure to be here to explain you what we are doing. And it's quite correlated what we have just talked in the last presentation. What we are doing in 𝗕𝘁𝘁𝘁𝗍, it's focusing on the transition that we are doing. We know we need to change sustainable, renewable energy sources. We need massive energy storage for those, you know very well, but current batteries, you know very well, have limitations like the price, cyclability, just have pointed out recently, the recyclability issue too, but also, for instance, power or critical materials. And power is something very important because energy is, energy is just half of the equation when we consider a complex system like a grid or an electric world that we are moving. So it happens that systems that have low prices for energy have high energy for power, and the opposite is also true. And depends on which time, which scale, there are applications or energy storage systems that works better than others. We are from Spain, and in the last year, the ancillary services has increased a lot. The cost for the 2024, we need to check it, but recently for 23 to 22 year, increase of 44.7%. Are the services just to balance the grid? because of the fluctuancy, because of renewables. In Spain, we have a lot of renewables, 25% almost. Worldwide, it's just 50% around. Think about what would happen if we change that from a 70, 80% worldwide. How much energy storage do we need? Do we can solve that with current technology batteries? That we think that that's an issue for that, most for the flexibility that we would need for a grid based on so much renewables because of the intermittency. So we think that current technology batteries have limitations and we struggle to fulfill that. And that's precisely why we are developing a solution completely different, focusing on provide high power and at low cost, which is the most expensive energy storage capacities. So our technology is based on use rather the common thin coatings, electrodes used for all technologies nowadays, just a paste. We use a paste and we inject it to the cell. That allows us with a paste to work with thick electrodes, something that reduce cost, increase energy density at the cell level. We avoid use any critical materials. We work with basically nanocarbons. It's a nano paste based on carbon, so material is not critical. It's easy to manufacture and recycle. Now I'm going to point out that. And we focus on a hybrid supercapacitor technology. Now I'm also going to explain you why in detail. But these are the core of what we're thinking. So the manufacturing is now one of the critical points for cell batteries. I mean, we're talking about billions of investment in CapEx for a manufacturing. It's extremely complex to do current batteries. So a method like that, which is just inject the material, inject the active materials mixed with the electrolyte into the cell, close and get it work, is what we have developed. We are doing that at ambient atmosphere. And our aim is do the recycling through the same mechanism, just putting in more material, pushing out the other reuse. So reuse the cell, which is very important, first reuse and then recycle, and we get the materials. And it's obvious that it's a very strong reduction on the capex needed to manufacturing and the cost of manufacturing, and making something for sustainable, for circular economy. The hybrid supercapacitor is because supercapacitors have nice advantages. They have, of course, disadvantages, energy density, voltage, but we face that. We face that basically by the use of thick electrodes, hybrid technology that help us to optimize the energy density. The voltage is something we can easily solve through bipolar configuration of the electrodes, something that usually is very expensive, but by these methods of manufacturing, something we can apply without an extra cost, barely extra cost. And supercapacitors provide you also advantages from the BMS and the temperature control. I mean, it's far more simple. You don't need to make complex models and understand your battery and control the state of charge. It's a nightmare for a complex battery or how it's aging. Now it's just internal resistance and far more simple and predictable. So all that helps also to simplify the module or battery pack. Again, removing more materials, connections, make it simple, and again, making cheaper also, and making more efficient. Like we're looking for thick electrodes, so and that's another way we are looking to narrow the distance between the capacity we can get from this kind of technology from a battery. Looking for being the same order of magnitude. We do not expect to get the same values of a lithium-ion battery, of course not, but not to be 2 orders of magnitude, be the same order of magnitude, but with a hugely high power life cycle like supercapacitor, which is crazy, and a very reduced cost. I mean, the point is that apply a solution that allows us to reduce the cost of high power energy density systems. So to open the door to use these technologies to far more applications in which just because the cost of the watt hour for supercapacitors, flywheels, or other technologies like that was very expensive, you can apply those. So running out, I think I'm almost at time, just last slide. We are pre-industrial cell and we are looking for partners and investment to hopefully in 2026 start getting a pilot or proof line to making the definitive cell. Thank you.
Any questions? You can left the team, so I can see the team as well.
Yeah.
You're located in Barcelona, correct?
Yes. We are a startup and a spin-off of the Catalan Institute of Nanoscience and Nanotechnology. That's where we are developing the technology. And it's a research group which is expert indeed in this hybrid technology.
Okay, any questions? If not, we'll do a commercial quickly. So the industry commercial comes now. And so if you want to present yourself in battery innovations in Spotlight, I've shared the link. I shared the link to the person currently. Hold on. I will share the link to everybody. Now here we go, TraWeBa.de im Rampenlicht. If you go there, let me quickly share my screen. You share my screen, the right one. Yes, here we go. You will find if you do that, you can check the dates when we are presenting. It's always the second, so the May comes in soon. It's always the second Thursday in the month. So I think in May it's the 3rd. So if you want to apply, just select one or select none. If you're not specific to this one, provide your name and your organization. We contact you to bring you here, and then you can present your innovation, your way to target in the end of the day, or to make batteries production faster, because batteries will, I believe, be the solution in the end of the day for the climate change, because the sun is for free. And if we can produce batteries and they're getting, I don't know, in terms of capacity, in terms of price going down, capacity goes up. At some point in time, we'll definitely have a nice way. If we do it quickly, we can be successful. Okay, but with this one, please apply there if you're interested. And with this one, we're coming to our last pitch.
Yes, and I'm happy to introduce now Dennis Schmitz. He's from Green Engineering. I hope I pronounced that correctly. And he will explain something, or his title is The Layout of Battery Housings, Multiple Jobs, One Approach. Dennis, the stage is yours. You have 4 minutes.
Okay, thank you, Maximilian. So, let's go. Yeah. So I hope you can see my screen. So as you said, I want to share some insights with you about the layout of battery housings, multiple jobs, one goal. As many of you know, designing and developing a battery housing, no matter if it's for automotive or aerospace or new mobility, goes along with many different requirements. So we have some essential requirements like thermal propagation strategy. We need EMI shielding. We have some beneficial requirements like a proper thermal management to increase the efficiency. And also we have some appreciated requirements, let's call it like a service concept. So during the use phase and end of life, that there's a benefit also for the customer. And on the other hand, we have different applications, different customer in one application, who have a specific approach for the prioritization. So that means we need to match the targets of these customers, these applications, and fulfilling all the requirements at the same time. Therefore, and this is more now an automotive focused example, let's say, but this could also be truck or an EV2L or what have you. But looking to an automotive, first of all, we need to think about from a pack level to a system level. What do we need to consider in case of a passenger car, for example? We need to guide the venting, take care of the crash management, also consider the vehicle dynamics, and also make sure that this can be assembled and disassembled in a proper and efficient way. On the pack level itself, we need to think about the design philosophy. So do we want to follow a more differential design, which is scalable, for example, which allows material mix and so on? Or do we take care of a more integrative design, thinking about larger production volumes and more flexibility in the shape of the battery case itself? And very car dedicated now, there we talk about cell to model and cell to body. So the way we use the synergies between the vehicle and the battery case can vary quite a lot. So at the beginning, we saw many kind of add-on layouts where you have just a standalone battery mounted to a car. And then car manufacturers like Tesla is a very prominent example, but also BMW's new class. They are following quite a very synergy approach. So actually body floor and battery cover, for example, is the same. And by that you can gain some package space to improve the volumetric energy density. Apart from the layout, we also need to think about the technologies we can use. So thinking about multi-materials, steel, aluminum, classical metal structures, let's say, but also thermoplast and thermoset reinforced plastics with glass fiber, carbon fiber, or natural fiber, which is coming more on vogue these days. So, and then we have different requirements on the design itself. We need to think about form sheets, about nodes, which can be casted, injection molded, and so on, or just about profile sections. And depending on the material, depending on the manufacturing process, they are more or less proper for a targeted production volume when talking about capex and part costs. Choosing a certain technology, we have to test it in a hardware, especially for functionality like flame retardancy, or also electromagnetic shielding or so on, whatever you can think of. First, you start at a test sample level. You can try many different things because solution readiness must not be that high at the beginning. It's about getting an overall picture. But then in the further down selection, we need to be very goal-oriented to also take care of the development budget. And this is a very important thing to always develop phase adequate. And the same is also true for the virtual validation. So as simple as possible, as complex as needed. And also there you can increase the level of complexity during the development phase and can save quite some budget and time during development projects by experience. So finally, multiple jobs, one goal. The goal should be that we ensure a functional, ecological, and economical performant battery housing. So realizing eco-design actually. When working with me, you can take care of, or you can take advantage of capable tools and the following skills, just underlining the interdisciplinary battery requirements so that the structure, thermal and electrical requirements can actually meet each other.
So you can already 2 hands. That means your
okay.
last
okay. Yeah. So the further points just highlight. So like out of the box engineering, and you can take benefit of the experience based on OEMs and TS projects. Here below you see one of the published projects. Many others are still confidential. And yeah, thanks for your attention. If you are interested in conceptioning a battery housing and bring it to prototype manufacturing, please feel free to reach out to me.
All right. Thank you very much for the
link.
talk.
I just shared the link of Dennis in the chat. Sorry, Max.
No problems. All right. Yeah, we have already the first question in the chat. So with a look at the time, let's switch to that. 𝗕ጵ wants to know what is the impact of the new EU battery regulations on the design of battery systems, especially easy replacement and repair.
Yeah, that means that you have to find the right balance between pure performance. So in the past, it was very performance oriented, and also you wanted to ensure the ceiling. And now with this initiative, you actually have to take care that the modules and cells can be replaced. Also, the choose of, let me say, more eco-friendly materials and manufacturing processes is appreciated by that initiative, which is actually a positive thing, definitely.
Christoph, is that answering your question?
If you guys want to ask a question directly, please raise your hand. That's one from Simon. How do you see the relevance of reinforced polymers in sustainable package design?
This is strongly dependent also on the targeted production volume and on the design freedom you need. So when just talking about classical shoebox battery housings, let's say, you can get along with large sheets and so on. But if you increase the design complexity, these reinforced polymers are reasonable, and depending also on the matrix, because depending on the matrix, you can have a quite different carbon footprint. And then these polymers need to fulfill the functional requirements, especially like hygroscopy. So for polypropylene, it's different than for nylon, for example. Yeah, so they are also an enabler when you take care of the joining concept to metal structures.
Perfect. I think we have time for one last question. If somebody has a question for Dennis. Otherwise, Dennis, I thank you for your talk. And Holger, I hand over to you again.
Yes, thank you everybody for joining here. So the next presentation or the next session will be on March 13th. I hope I'm correct. If not, Paul Elias will correct me. It's again 16:30, but we are back on Thursdays because I think Thursdays are much better. So we will find everything on LinkedIn soon. We will send you the links as well. If you're interested in connecting with me in terms of, I don't know, presenting to battery innovations in the network, in the spotlight, I just posted my my link into the chat, and would be happy to pick that up. So we are cutting all these videos. Please like the stuff in order to get reach. And as I said before, we have the link in there as well. So if you want to present here in battery innovation in the spotlight, let us know. If you want to understand how you can build a scalable sales process in order to grow such a network, let me know as well, because that's what we are mainly doing. And this is something which is simply mathematics and a little bit of work, and you only need the right strategy for that. So thank you everybody, and we will definitely have, and the March session I think is already quite full, so please apply soon. And then we will see you next month, March 13th, 4:30 p.m. Thank you, everybody, and see you next time.